this is not very. Oh, well, hello everyone. On today we continued the building and reprojection and SRTM file viewer. I hope this is live. I hope there are people seeing this. So in the last stream we had the problem that our points that we reprojected did not show up on the screen. And I shortly want to explain what the bug was and how I fixed it, and well, it's working now, and I've put all of the put the fix on GitHub. So it's not a huge issue, but often it's better to take some time out and just think about the issue. I'm getting my drawing tablet, so please just wait a bit. I hope this stream has improved audio. My microphone isn't really great, but I've removed the noise filter because it simply sounds too muffled. Sorry. So let's connect the drawing tablet. Wait. So I hope this is working as expected. Yeah, it's a bit sluggish, but yeah, that's to be expected. So I shortly wanted to explain what the bug in the last episode was. What I told you was that we have this this area that we're looking at, and this is not very nice. We are subtracting our points from the south and the west coordinate. So this is basically the distance here. And the problem was that this southwest coordinate, southwest, this was the wrong southwest coordinate. So if you imagine this, violet thing, this is our screen. So this is how I wanted it to be, so that we have the actual image always in the bottom left corner, no matter of the scale. If we scale the whole thing, then this will just grow larger than the screen, and then we have like a red box like here, and this will be cut off. But for the most part, it should fit on the screen. So, and I didn't know what was going on. So the problem was that I didn't use this southwest coordinate, but I actually used the southwest coordinate of the whole texture, which is down here. So I was basically setting the wrong display somewhere here, and so all of our points were basically off screen, and so we did not render any points. So this is the thing that I've fixed, and it's fairly simple. So I also wanted to go about how to debug in Rust, because this is something, you know, in the last episode I was sort of doing stuff with printing out certain values, and you don't have to do this if you have a debugger. Debuggers are very, very helpful. So let's look at the fix. So basically the fix is that we store the display bounding box inside the display region pixel, and for clarity, when we load the data, we set the display region to this one, and this bounding box is the bounding box that we get from here, which we want to display. I also verified that the bounding box is basically on the texture, so that we should not have any problems further on, because, you know, I could be zoomed out anywhere, anything can happen. So just wanted to verify shortly that we are live. And you can actually find the stream, otherwise it would be rather sad me just sitting here. So if you can actually find this stream, yes, you can find this stream. So let's work on this a bit more. So if we now run the program, you should see green points. And this is also not, so you see all of these green points, and they do go in a sort of order, but yeah, and this curvature is actually wanted because this is technically the curvature of the Earth. However, the problem with this is that it's not at all what I expected. So it's not what I expected, but maybe we can change this. So first we want to render points and make sure that the points are actually where we want them to be. So we can go into the documentation and search for points, polygon index. First we have to set the index to the when we draw primitive, so we want to draw points, and then when we actually draw surface frame draw parameters, this is where we can say, okay, we want the polygon mode to be points, and we want to set the point size. The point size has to be somewhat lower than 10, which is something of the which is defined by the OpenGL library. So if we draw, we just say, I always forget the syntax for this. Oh yeah, we say draw parameters, then we create like a struct, and then we fill the rest with the default implementation. So, and here we can say, okay, here we can say polygon mode equals is a polygon mode of type point. We want to render point. So someone has just joined the stream. I wanted to shortly explain what the problem of the last episode was. So I explained it now, but basically I was rendering, I was assuming that this point is the southwest coordinate, but in what I was actually doing was taking this point. So this green thing was where I set the display in the last episode, and here up here were all our points, and this is why we didn't see any points on the last episode. So if we now run this program, it does not compile. Expected a reference, yes. Hope this will somehow work. No indices, just the points, yes. So this is where we are now. These are all of our points of the, this is what I wanted to see. This is what I wanted to see. So this is, and if you look here, the image is not exactly, not square. So these are all of our points, and they all have texture coordinates. And now we're going to simply project a texture using these points, right? So now I've actually set the coordinates correctly, so that didn't change anything, but this was certainly correct. But if I've just set this to the wrong southwest point, so all of our coordinates were off screen. Right, so this is what we have now. Now the next thing that we want to basically render is we have all of these points, we have all of them projected into the screen, which is nice. So the next thing we want to have are indices. So what, yeah, I'm just making a new document, whatever. Yeah, so what are indices? What are indices? Just wait a minute. Right. I hope I can explain this. Right. So we have all of our points, and they all have a number, right? Like 1, 2, 3, 4. And then we have the next row of points. Now the next row of points here is n, where n is our width of the projected texture. So here we have n plus 1 and n plus 2. So everything that we're trying to do is just put the one thing plus 1 plus 2 plus 3. So how OpenGL wants to have a quad rendered is basically we want to have triangles like this in this direction, right? And then this in this direction, so that they are facing towards us, and then we can use our texture coordinates and say, hey, please draw a texture onto these points. Right. And these are all of the points. So we basically have to say 1, 2, n plus 1. So which is our first 1, 2, n plus 1. And then our second triangle is n plus 1 plus 1, 2, n plus 2, n plus 2. And these are our triangles. So let's try and just make this. So I'm trying to use a graphics tablet, and I'm also trying to improve my sound quality, but yeah, well, it's just an attempt. So we have our best way is just to put this in the data data file, where I've basically put all of the miscellaneous function that we don't really, we can also, again, we will probably implement some sort of closing function, but I'm not really sure for this episode. So generate the indices for the quads, so that we can not only draw points but actually draw quads. So we need a width, a height, and a that's it basically. We need a width and a height for the quads. And what we get back is a vec of u32. And then we can later on make an index buffer from this vector. So this is not fairly idiomatic, but it's easy to read. So we let the return vector back u32. Again, you don't have to do these annotations, but I wanted to say tomorrow I will be trying my first sort of lesson to teach Rust to beginners, and sort of go over why you would want to use it, what are the benefits, what are the drawbacks, and so on. So let's just make a time. Let's say tomorrow is Sunday, so everybody should be there. So the current time UTC 15:54 is, I'm +2 UTC. So if you can check back maybe tomorrow at this time, so 6 o'clock p.m. 6 p.m. at my time, and your time roughly right now. Then we will start a roughly 2-hour lesson of teaching actual Rust, writing Rust, setting it up, getting things to run, how to debug, etc. etc. So if you're interested, check back tomorrow at roughly the same time. It's Sunday, so should be ready. And in this series, I'm just using Rust, so it's not like I'm actually teaching anything, but this is just me writing Rust code. So we want to have these sort of indices. Yeah, shouldn't be too difficult. For x in 0 to width, and then for let's say y first, 0 to height. For x in 0 to width, we need to make this mutable. Then we use the first triangle, the second triangle indices, return vector push, turn vec push the x that we are currently, turn push x, then we push the x plus 1, and then we push the x plus the width. So yeah. No. We need to use the x y times width plus x and y times width plus x plus 1 and y times width plus x plus width. The height is exclusive to height minus 1, I think. This will be, yeah, this should work. So now what we need to do is to copy this and then we would say then we would push this one first, then we would push the second coordinate, which is this one, and then we would push the n+2, which is just this. And then add 1. Yeah. And this should be it. Right. So if this worked, we should have the indices. So index buffer can let index buffer equals data generate indices, and then we need to have the this dp display region the number of pixels horizontally and dp region px vertically. These are only the points. Now to actually calculate, make a vertex buffer, what we need to do is this make vertex buffer, what is the actual function? I always look at the examples, so that's where I know we don't for the indices. No, here's not the no indices, but oh well. Index buffer new. So index buffer new primitive type. What primitives do we want to draw? If we look at the well, we could we want to draw 0. Yeah, we want to draw it like this, which is, oh, we don't actually need any of this. We just need the sum tab. So we can just go ahead and say, okay, we sum points index buffer. So that points we should call it just index buffer equals index buffer new. So this is imported from here. Index buffer new, and then we need the facade. The facade is basically a reference to the display, reference to self.display. because the OpenGL context is bound to the window, so we need to say, yeah, right now we need to say how do we want to have these working. The easiest part is just triangles list, triangle strip would be this, but triangle list is a bit more convenient. Triangle strip is of course more memory, not as memory hungry, so let's use this. And then the last parameter was, yeah, the actual points. Right. And then we can just say the index buffer. So if we try to, yes, there are a few casting issues. There always are, you always need to be aware of these casting issues. Casting U32 as U size, so generate indices. In this case, it's easier to just say that not have this a U size. However, U size is basically either U32 or U64, depending on if you run this, if you compile this program for as a 32-bit or 64-bit executable. So this will be at compilation time be 32-bit or 64-bit. One of them. But yeah. Let's run this again. Index buffer. Expected. Yeah, we need to unwrap this. Unwrap. Right. Now if we, yeah, we don't actually use the index buffer, but let's see if it works. Well, it worked. So let's kill this. So let's just say so if we don't have an index buffer, we only draw as points. But if we have texture display region.index buffer. So if we have a index buffer, we can use it, but if we don't, we just draw them as points. And then we can use a command. Well, seems like this seems to be the correct thing. So we can basically copy this and then paste this, and we will use the, instead of doing this, we will use the indices, and then how we actually want to draw is just the default default implementation. Right. Yes. This should give us one huge quad, basically. And does it? Yes, it does what we want. Now, since this is OpenGL, we can simply enable multi-sampling. Yeah, I think we need to do some changes to this window. But it's looking how I expected this to be. Now we can, this is something that you have to do when you start the window builder. So when you have this window builder, I think it's either in the window builder. So in the window builder we can basically set something like the dimensions with full screen. Should we have full screen? No, we don't. This will become important later on if you want to hide the window. Transparency. And then we can just say, okay, we want to have a window builder. So just say this is SRTM to image. Now this is context builder. With multi-sampling and let's say 4. That should be fairly standard. Let's build again and see with multi-sampling multi. So in this, this is what we have. With sRGB not enabled. So the next thing is to load. Yes, is to load the shaders main.frac. Here we just go by the texture. Uniform sampler to D, sampler to D, text and color equals text vtext chords. in vtext quotes color equals texture. Yes, that's the and then we have text text quotes. Right. So next thing is we need to bind the texture, which is done by doing something uniforms text texture. So texture glium texture 2D new. Right, so this is what we need. Texture data. Yes, so we need the glium texture, which is a we don't need the final data, although yes, we need the final data, but glium texture is basically now we are storing the image that we created up here, and create texture from image, and then we can use glium texture from raw image 2D with height client format U8 raw image 2D. Yeah, we need to construct this. Raw image 2D. So the data is a reference to the the data is image. Raw image 2D is the data from the final data is a back U8. Final data width is with height, and the client format is glium texture client format unsigned 8. unsigned 8. So then we need to make a texture from this and basically say okay, Skleum texture, use Skleum texture raw image to 2D and texture, and then the texture will be the texture as Skleum GL texture, and this will then be a GL texture. So this should work equals GL texture and texture TX. And this should work. Texture 2D GL texture new reference self dot display image BO. Yes. And the data will be a reference to the final data. Yeah, we don't. We do not want to. This actually. Yeah, okay, so it does. Use standard borrow. Use standard borrow. Copy on write. Hopefully this should work. Oh, I did not bind the texture. Compilation error unexpected. Color equals. Wait, what? Color equals texture text vtext chord. Text vtext chord. uniform sampler to the text. Yes. Unexpected semicolon. Unexpected semicolon in vtext quotes. In vec2. Right. Now all we need to do is to open window and say, okay, the uniforms have the text is a reference to a texture. Yes, so this is what we have. This is what we have, and it's not well, it's not great, but it's something. So we need to basically tell it to, okay, we have multiple problems now. We have first things first, we just want to say, okay, handle window event. Yes. Yes, we want to say so if we get an escape key, we close the window, because that's getting fairly annoying. Now if we redraw the screen, save the window resized. So this should returns if the screen should be redrawn or not. So let's clean this up a bit. By default, we will just return false. And if the UI window was resized, then we want to say okay. We want to return true. If none is returned, we want to close the window. So this would be some true. We want to redraw. Else we want to say gluten window event, else some false. If this fails, yes, some false, so that we don't need this. Else if let routine window events key whatever key window event received keyword input received character, let's say received character A, then we want to return none, and otherwise just return false. So self-handle window event, match self-handle window event, some true. We want to some none, we want to break the outer loop, then if it's some false, continue the outer loop, and if it's some false, and else just don't do anything. So this means that we can drop all of this as well as this. So received character as if let equal event outer use of undeclared label outer loop inner loop break outer outer loop do not understand it, but let's see. Expected type does found so for some reason it does not want to handle this if let gluten event equals event. Oh, because this is a closure. So of course this is just completely bad design, but closed equals true. Not closed. If it's none, we say closed equals true. If we say some false, if should redraw, if not should redraw, just continue. So we just say should redraw equals true to draw on the first frame, and should redraw equals false. Some false, some we say some true, we say should redraw equals true, and otherwise we don't do anything. So return some true. Let's see what we get. If this works and if this redraws. Yeah, problem is events loop. Events loop. Poll events and forever. When an event happens, calls the callback. from event loop. Run forever, control flow, continue. So yeah, this is pretty bad, but hey. So we just say okay. Let's see when we are actually drawing. So I'm not drawing. And this is probably one of the worst things that could happen. Right, but we do have an image, right? And if we say A, yeah, that's the problem. We still need to just say just completely crash the application. So problem is that we exits cannot find exit. Must exit application. Standard process exit. Just completely shut down the function run app exit standard process exit 0, because yes, we will have this in a later episode. Let's see if we can actually make this a bit better. We just say A, just exit. I know this doesn't free up any resources and sort of stuff, but yeah, it's faster to do right now. And I think the driver will clean up this sort of stuff later on. So yeah, we shouldn't actually call exit, because exit is sort of dangerous to do. So yeah, this will not run any destructors, which is a problem. Yes. But we don't draw every second anymore, so this is also something to note. Now the next thing that we want to have is to shaders main.frac so in order to do this, I have written this, I wrote this in a closed monochrome textures. Right. This is what we have equals curl color. We do this. What we get is a monochrome texture. Right. This is our texture. So this is what we have right now. And if you compare this to the image that we had, this is somewhere, I don't actually see where this is, but you can see that it's already reprojected it to the sort of correct scale. So this would be probably, I don't actually know where this is. One thing to note is we need to use RenderDoc again. This will probably, file, launch, target debug, SRTM to image, launch, trigger capture, trigger capture doesn't work, doesn't want to work. Alright. Does not want to work. Why? One core context in use. Well, close. So this is where we are currently, and to be fair, it's looking fairly well. So all I want to do right now is to close RenderDoc, kill all SRTM, and then just say, alright, if we have the polygon mode, just indent this please. Yes, thank you. I don't know why it didn't work before. But yeah, we need to, what we need to do is to say, let's just save right here, right? So the next thing that we want to do is not to render directly. Well, I actually wanted to see if the data function, if this was wrong. Right, if this was wrong, we wanted to have this working, sort of. Yeah, no, it's not better. Still has this weird bug where it's going, where it's just sampling downward, but problem is that there are no points. There are no points in this area. So I'm kind of wondering why and how it gets these points. So yeah. Well, it's Saturday, so we don't have to finish all of this in one go, but this is sort of where we currently are. Right. Well, I hope you enjoyed this stream. We have basically reprojected the image because now it's not, if you look at this is fairly stretched. This is a bit stretched, and here we don't have this stretching anymore. So I think this is somewhere, I think we are somewhere looks like it's this region somewhere here, but again I'm not quite sure. We are zoomed in a lot, so yeah, I hope this made some sense to you. So we went over what vertices are, what indices are, and for the next stream, which will be I will do an intermediate stream at Sunday, tomorrow morning maybe, and then I will basically go over how we would either tonight at sort of 10 to 12 p.m. or tomorrow. So then we would go over how you would create a shading from this sort of image, because right now it's not, or what we need to do is to render to a frame buffer. So we could still do this in the current stream. So we just hit A, we need to render to a frame buffer instead of drawing directly to the window. So if we have a frame buffer, simple frame buffer, new display texture, to multiple color buffers at once, must use a multi-output frame buffer. Okay, we only need the must have the same dimensions. All frame buffer attachments must have the same dimensions. Alright, so texture. We want to draw to a texture. So we have the display, we have the events loop, we have the application data. So in frame buffer, we simply say, okay, this will be a GL texture. Right, and if we, this will be a texture that covers the whole screen. So instead of drawing to a frame, we will draw to a texture. And then we will convert for each thing, let frame equals, and then we will say simple frame buffer new, frame is a reference mute to the GL texture, and we also need a, well, it doesn't make sense. We can just make a reference mute to simple frame buffer, which will be the front buffer. So instead of drawing directly to the frame buffer, we say, okay, self.display self dot back frame buffer, draw back frame buffer. Right, and then we just say, okay, texture mute frame, and we should be able to say frame buffer to draws over texture. All we need to say is, okay, simple frame buffer new facade color, see where to color attachment. Let's see what we want to have. new two color attachment, so we can say, okay, we want a simple unsigned texture 2D. Unsigned texture 2D. Unsigned texture 2D. Yes. Unsigned texture 2D. But this would destroy our multisampling, so yeah, that's another thing to keep in mind. This will destroy the multisampling. Simple frame buffer. Use simple frame buffer, so we just make a simple frame buffer. The actual window. Yeah, we don't need the next frame time anymore. We don't need this, but we need a back frame buffer. Will be a texture sRGB unsigned texture 2D unsigned texture 2D. That. Then we say, okay, unsigned texture 2D. How's this actually? Texture 1D. Unsigned texture 2D. New data is T. New unsigned texture 2D. Texture equals we don't we don't have any dot work dimensions of so let's unsigned texture to the new reference display, and then we create a texture and say, okay, data with format empty with height and yes, this is what we want. So will contain undefined data. Create texture with undefined data. Back frame buffer is now simple frame buffer new. Simple frame buffer. Simple frame buffer. Simple frame buffer. New facade and color. New simple frame buffer. New display. Unsigned texture 2D. Two color attachment. Texture. Unsigned texture. Unsigned texture. Unsigned texture 2D. 2D map. Yes. Texture 2D. Sign texture 2D. Main level. Texture main level. So this will texture.main level. So this will contain undefined data for now, but we can say, okay, we can create a frame buffer. No, we actually need to say, okay, this will be an unsigned texture 2D. This should be a texture 2D. Texture 2D. So unsigned texture 2D. We have the empty frame buffer. No, what the? Okay, simple frame buffer. Okay, we need to say this is a unsigned texture 2D. Unsigned texture 2D. unsigned texture 2D, and we make the texture, then we draw as surface. Yes. We can just say, alright, we need a simple frame buffer. So what we can say is, okay, we need a self.back buffer mute self.back and buffer as surface. As surface will draw on the texture instead of the screen. First frame a following call to when the texture is destroyed, the FBO is destroyed too, which is nice. So we can say back frame buffer as surface, self dot back frame buffer. Do we actually have, yes, unsigned texture 2D as surface, empty, which is, yes, we draw onto this, and then we make a new function which just says pop function split back buffer to screen, which takes in a, let's say we have the window, and we have the function set, well, window. No, we have the frame, frame, because this would this will still split from simple frame buffer, right? We can say, okay, split from simple frame buffer, split back buffer to screen, split frame buffer to screen, display, so what we need is we need the display, okay, source simple frame buffer, frame buffer reference, which is, we need the source rect, yes, we need the frame buffer which is the split frame buffer to screen, which is we need the frame, and then we need the frame buffer, simple frame buffer. Then we need the frame dot get dimensions rect equals to rect. So we want to split the complete screen. We want a left bottom with height, left 0, bottom 0 with width, height half. So split from simple frame buffer, rect, and then we have to use the drawing options to say, okay, we want to actually interpolate the display, split from simple linear. Right. This would be frame. So we can say, okay, frame, this is draw to a simple frame buffer, and then output the result of this simple frame buffer again onto the display. So self draw self draw reference to frame, and then we want to have frame buffer as surface. This is not accurate, this should actually be texture. And so if we have let frame buff equals this, frame buff let mute, and then we have a reference to frame buff, and this should do the trick. So we can say, okay, back texture, unsigned texture 2D, so yeah, width and height. So back texture unsigned texture 2D. Then we make the width height. So what we need to do now is to open main, new, let's say width 800 and 600, and this should be it. So window texture rect, yes, rect, use glium rect. Back texture. Save. Oh, yeah. We need to so this function takes 4 parameters, but 3 were supplied. Frame dot blit from simple frame buffer. 3 were supplied. What option was not supplied? Blit from frame. Target rect blit target. Default. Oh boy. Derived default. Yeah, that's not. All right. We need to use blit target. Yeah, we need the blit target 0, 0. Left border of the rectangle, left bottom. Well, let's just copy this and see what we get. Source, yes, target, source equals the rect, source main, source h, and then target and target. Frame buffer. I hope yes. we have the get dimensions. So targets B and targets H. So source V and source H, frame buffer, get dimensions. SE32, 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 SI32. Expected U32. Expected reference. Let's see what we get. Nearest. Okay. Right. Well, that's just format conversion from unsigned to non-unsigned integer. Yeah. Invalid operation. Format conversion from unsigned to non-unsigned integer. Not allowed. Well. Format conversion from unsigned integer to non-unsigned integer. Well, I don't get it. Unsigned int to non-unsigned, so it's a regular int. Bit from simple frame buffer. So split text split frame buffer. Split name frame buffer. Split name frame buffer. Imports mem transmute. Which actual function is this? Split name frame buffer. Split name frame buffer. No, this is not self.split name frame buffer. So this is basically trace, and then we have frame buffer, draw frame buffer, mask, filter, mem transmute, extern system. As which function is this? Extend system function. GLint, 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 GLBitfield. Read frame buffer. Well, the just split frame buffer should not. Well, okay. Let's try this again with the A. Right. That from simple frame buffer, so maybe this whole thing would be unsigned texture 2D. So we just say texture 2D. Maybe. Texture 2D, new, empty, texture 2D as surface. So as surface does work. So as surface we draw to the texture and then read to pixel buffer. No, we simply say okay, unsigned texture 2D. Wait, but is the simple frame buffer texture 2D? So it does work with a regular texture 2D because probably the format is still signed in some way, and yes, does this work? So we still get the red frame. Yes. Right. This does not work. Generated source and destination must be identical with the current source and destination dimension must be identical with the current filtering modes. Must be identical. Source and destination dimensions. Yes. Okay, so I get it. Nearest. So we need to. Can we resize the texture? Can we resize the texture? Split color, split target. No. Can we need to resize the texture. Texture 2D. New. thing is, if you want to create a texture whose size can be changed at any time, do not use, instead pass some dummy but compatible values. Unless this is a proxy texture. Well, do we have something with a proxy texture? No, we don't. Well, for this example, yeah, well, I don't really care. I don't really care. So let's just end this and let's recreate the texture on each draw call, because the draw call is not yes. So split frame buffer to screen. Let recreate the texture. And then we just say, alright, let's height equals self.display.get dimensions. Then we just, yeah, this should destroy the previous texture. Otherwise we have a problem. No. So with height, let's see if it works, but we can see in RenderDoc if this is actually a problem. So we can say self.display and then self.back texture equals texture equals new texture. We create back texture because what was this? Well, whatever. Text storage 2D is immutable. This should be it. Yes. New get dimensions frame. Let's see what we get. if we get something. Do we get something? Yes, we can. This is now drawn to the texture and then to the actual display. So we recreate the texture every time we redraw. So yeah, we just split the whole texture, which is fairly fast. Yeah, the only problem is that now we generate a lot of events in this. This is not good. Well, so I think this is where we should leave it for now, because the next step is to make other frame buffers and then render into these frame buffers using, or basically right now our process of doing something right, stupid. No, I just want a drawing layer, please. Select, deselect. So our current process is to, where's my pen? So our current process is to, we have a back texture. This is the texture. Here we draw our image. So we use the main shader, just shader, to draw to the texture, and then we split it to the window. Right. So, and we just copy the whole texture to the window, because splitting is faster than actually sampling. So we could of course sample the texture, but splitting is significantly faster. And that's the frame start. So, and what we need to do next in the next episode is to get this texture and then just see, okay, we have this texture. What we need to do is to create a, can we actually draw directly into the frame buffer? I don't think so, right? We can create a texture and then we can draw into this texture, but we cannot draw directly into a frame buffer, I think. Do we have simple frame buffer? No, come on. Oh, yeah. Draw. We can draw directly into the frame buffer without needing a texture. Facade color to color attachment. Yeah, right. We need the texture. From this texture, we create a frame buffer. Right? And this frame buffer is sort of like a proxy for this texture. So if we draw to the frame buffer, we actually draw to the texture. And then what we need to do is we create another frame buffer, and then we take this frame buffer and this frame buffer, and then we start swapping them. And on each swap we draw with a blur shader, blur.fs. So and on each blur we create a new blur, and that's just and the amount of blur will be dependent on the amount of blur will be dependent on how far we are zoomed in and how dense the pixels have to be. Yeah. And then when we're done, we need to shade it. Shading. So shading is, well, it's difficult. Shading is very, very difficult. So when we have sort of this data, how do we shade it so that this region should be large, right? And if the light comes from here, this region should be white, and this region should be dark. So that's something to think about how we would do this. Again, tomorrow I will actually start teaching Rust. So don't expect an episode tomorrow. Tomorrow I will start teaching the basics of Rust, why you want to use it, how to use it, and yeah, that's sort of the whole concept. Thank you for listening, and that's where we are right now. It's quite some progress, but it's going very, very slowly. Thanks everybody for listening.